Hello there, this is Professor Eckhouse, and this is section 2.3, solving one-step equations. So you might want to take a moment to pause the video and see what it is that we're talking about here. I'm not going to read through all of these, but one little note I wanted to make is to use the introduction. The introduction page for every module has questions from previous sections to step you through some things that you need to know before you can do this section. So those are really useful, and they have little interactive problems and things that you can do. All right, so be sure you're using the book, including the introduction, the summary that has lots of equations, the try-it problems, and the videos. The links up above, all of these links right here in blue, all of these, those are links to the book in Lumen. So it should take you to the different sections of the book, and as long as you're logged in. All right, so there's lots of resources here. All right, so we're first going to look at determining whether a number is a solution of an equation. And we talked a little bit about that last time, I believe. We're going to do it some more. So finding the solution to an equation it's like solving a puzzle. You're just finding what makes this statement true. So we're trying to decide if these things are true. So example 1 says, determine whether x equals 5 is a solution of this right here. Okay, so what we're going to do is we're going to take this 5 right here and we're going to plug it in every time we see an x. Okay, so we've got 6 times the 5. Okay, so the 5 goes right there. That's where the x was. Minus 17 equals 16. So I talked about this before. Use parentheses every time you plug in something for another thing. Okay, so it helps it to stand out. It also keeps you from making little mistakes. Okay, so 6 times 5 is 30, minus 17 is 16. So 30 minus 17 is 13 equals 16. So is that true? Is 5 a solution of this equation? No, it is not, because it is not true. In other words, I'm going to use the not equals symbol is not equal to 16. So the answer is no. X equals 5 is not a solution to that equation. Okay, it's not a solution. All right, example 2. Determine whether y equals 2 is a solution. So for this and all of the future examples, this entire lesson is examples pretty much. There's a few little things that I'm going to talk about, but it's mostly examples. Pause the video every time, whether I say so or not, and try the problem. You will learn so much more from all of these videos if you do that every time. Okay, so we're supposed to determine whether y equals 2 is a solution, so we need to put this y equals 2 in every time we see a y. Okay, so I'm going to say y 6 times, I'm going to put a blank there, minus 4 equals 5 times y, and instead I'm going to put a blank, minus 2. Okay, so I rewrote the equation with parentheses and an empty spot, and that empty spot is where I'm going to put this 2 to see if it makes the equation true. Okay, so 6 times 2 is 12 minus 4 equals 10 minus 2. 12 minus 4 is 8. 10 minus 2 is 8. That is true. True. So the answer is yes, it is a solution. Keep missing my eye. Okay. Modeling the subtraction property of equality. So we're going to start with this model right here. So we have this envelope, and it is supposed to represent a question mark of how much is in the envelope. We don't know. So, the model, the way this works is you basically think, all right, what would I take away here to just have the envelope? And I would have to take away the same on this side. So that means that the envelope must hold 5, right? So in here is 5. All right, so that's a little tedious, but it works. When you have a lot of numbers of things, it's a little difficult. This is something else you may have seen at some point, and that is the idea of the scale. If we have an equal sign, right, an equal sign, the scale is even, right? The two sides are the same. So this this purple right here, diamond or whatever I'm going to put there, the blank thing is going to represent the variable. Okay, so some unknown thing with a 3 is going to equal 8. Okay, so it's the same thing as what we had right up here. Some unknown thing with a 3 equals 8. So this was 8 right here. And this was 5 plus 3 equals 8, right? So the 5 and the 3. Doing the same thing with this right here. So stare at that for just a moment and see if you can make sense out of it. And we're going to use this picture, this type of picture for a couple more problems. All right, so we're going to solve these equations using the subtraction property of equality. So for any numbers a, b, and c, if a equals b, then we could subtract c on both sides like we did right here, and they're still equal, right? They're still equal. I'll do that in a different color. They are still equal. All right, so let's look at example 3. I'm showing it to you with a picture, and I'm also going to do it with just the rule, right? So the idea here is that the blue weight represents x. So x and 8 together, and we can put a plus between them if you think of it that way. Since the scale is equal, or is even, then that means they're equal. So this x right here plus 8 equals 17. So let's write it down. X plus 8 equals 17. Now, this property up here says that we can subtract the same number from both sides. It's going to stay equal. So I can subtract 8 from both sides, and the 8 is going to subtract out to make 0. So there's nothing left there. All I have left on the left side of the equal sign is just the x. 17 minus 8 is 9. So that means x equals 9. Okay, so you can always check that by plugging your 9 in here, and you get 9 plus 8 equals 17. Is that true? Yes, it is. Check. So that's our check right there. That's our check. All right. Okay, so why don't you try example 4 without me? Just take a look at the picture and then do it mathematically. All right, so I'll start with a picture. Remember the scale is even, so this means equals. This circle right here represents our unknown. So some unknown plus 74 is 100, and that's, oh, our unknown in this case is y, so that's fine. We'll make it a y. All right, so we've got 100 equals y plus 74. Now, how are we going to get y by itself? Well, we care about two things for y. To solve for y, y in this case, it could be x or whatever. 1, you want it alone, and 2, you want it on top. That is it. It can be left or right. It's okay. It doesn't matter which side of the equal sign it's on. So that's what often confuses people. Leave it on the right side because that's where it is, so let's leave it there. Because remember, we can switch the two sides anytime, right? We can make this y plus 74 equals 100, and if that makes more sense to you, change it to that before you start. All right, so I'm going to subtract 74 from both sides, and I'm going to get 100 minus 74 is 26, I believe. So 26 equals y. Okay, so let's check that. Would it make sense for this to equal 26? So 26 plus 74, does that equal 100? And yes, it does. So it checks. All right, solve equations using the addition property of equality. These are a little harder to do with pictures, so I'm not going to use pictures anymore. We're just going to do it mathematically. But for any numbers a, b, and c, if a equals b, then we can add c to both sides. Last time we subtracted, now we're adding, and they are still equal to each other. All right, so this works if it's subtraction. That's how we're going to get rid of things, right? We're going to add the subtracted thing and make it go away. All right, so let's look at example 5. X minus 5 equals 8. So I'm going to say, well, if I just added 5 to both sides, minus 5 plus 5 equals 0. Right, so that becomes 0. So x equals 8 plus 5 is 13. And that's all there is to it. All right, let's continue on. And we're going to see some harder ones later, but I'd like you to get used to these. And remember, with the video, you can pause, you can back up, you can slow it down or speed it up. All right, so again, here's another one where a, the thing we need, is on the right side. That's okay. You can leave it on the right, or you can just switch the two sides and rewrite it as a minus 16 equals 27, and then start, if that helps you. I'm going to leave it as it is because I want you to get more flexible, and so you can deal with it on either side. So I'm going to add 16 to both sides so that I can get that a by itself, and the 16 is going to subtract out to make 0. 27 plus 16 is 43, and that equals a, because all that's left on the right side is that a right there. All right, so our answer is 43. And you can check that by saying 43 minus 16 equals 27. Is that true? Yes, it is. So 27 equals 27 if you want to take it one more step. It does check. All right, translate word phrases to algebraic equations. Some words that mean, oh, I think I made a mistake there. Some words that translate to the equal. Okay, so some words that translate to the equal sign. Is equal to, is the same as, is the one you're going to see the most. Gives, was, will be, anything that basically is the is verb is equals. So anytime you see any of these, that means equals. Okay? All right, so it helps to write on word problems. This is my tip here for these problems. It helps to write on them. So if you're using OneNote, all you have to do is copy the page, and you can trim it, and then just hit copy, and you do that by doing a screenshot and then paste it into the problem right in OneNote, and it's so easy to do. All of these things right here this is how I did this. These are all screenshots from the book. All right, then you can write all over it. You can circle and all sorts of things. All right, so we need to translate these into algebraic equations. The sum, all right, so let's take this one thing at a time. Sum means plus, is means equals. Okay, 6 and 9 means the sum of 6 and 9 means we're going to say 6 plus 9. Well, is means equals, and 15. Oh, look at that. We got it. 6 plus 9 is 15. The sum of 6 and 9 is 15. Okay, so you've got to just step through it one word at a time, circle things, underline things. The product, so product means times, right? The product of 8 and 7. Okay, so 8 times 7 means equals 56. So practice these with numbers, and then when we start using algebraic symbols, it'll seem easier. Okay, so this is just the simple practice. Twice the difference of x and 3 gives 18. Now, you've got to be careful. Twice the difference, so that means 2 times the difference of the two numbers. So the two numbers are, I'm going to change colors here, x and 3, x and 3. When you say difference or quotient, you put them in order. X and 3 means you're going to subtract x minus 3 if you say difference of. Gives, all right, so gives means equals 18. So it doesn't say to solve it, it just says to translate it. So that's how you would do that. All right, translate to an equation and solve. Okay. 3 more than x. What is 3 more than? 3 more than. I need to do that whole thing right here. 3 more than means 3 plus x. So 3 plus x is equal to, that means that 47. So let's write this neater. 3 more than x is equal to 47. These take practice. That's what Lumen is for. So you can try them over and over until you get it. Now we're supposed to solve. Okay, so we're going to say we want the x by itself. We want this by itself. So we're going to say minus 3. Okay, so since it's added, we subtract. If it's subtracted, we add. Okay, so you do the opposite. And we get x equals 44. And you can double check. 3 more than 44 is 47. Is that true? 3 more than 44 is 47. I would go back to the words so you can really make sure you did it all right. Okay, example 11. Translate and solve the difference of y and 14. Difference means minus. Y and 14 means we're going to say y minus 14 is equals 18. And now we're supposed to solve. So I'm going to say plus 14 to make the 14 go away on the left and go over to the right is one way to think of it. So then I'm trying to get my color here, sorry. Y equals 18 plus 14 is 32. So the difference of 32 and 14 is 18. Does that make sense? The difference, I'll erase this right here so we can talk about this. The difference of 32 and 14 is 18. Is that true? And yes, it is. All right. All right. So I believe that's all I have for this lecture. Thank you for watching.